Hello Huskies, let's talk about functions and some features of functions that you're going to see. We're going to kind of step through the classwork a little bit. Our objective for the day, I can identify important characteristics of graphs and tables. So the first thing we're going to look at is this floating down the river problem, and we're going to look at the table. And the question that I'm going to ask at the beginning, when is the river getting deeper? So this river is getting deeper, starting from the very beginning. It starts at only 4 feet, and then it gets deeper all the way for the first 30 minutes until it ends up being 10 feet deep. And then it gets more and more shallow for the next 30 minutes until after 60 minutes, it's pretty shallow. It's only 4 feet deep. And then it gets deeper again, and then it gets more shallow. So you can kind of see just from the green arrows that the river is getting deeper. It's building up to a maximum depth, and then it gets more shallow, and then it gets deeper, and then it gets more shallow. So the answer to when is the river getting deeper is between 0 and 30 minutes. Also, it's between 60 and 90 minutes. And when is the river getting more shallow? That is going to be between 30 and 60, or also between 90 and 120. Now, a lot of people say, well, why 60? Why don't you say start at 70? Because we already used the 60. Well, because the second you have passed this 4-foot depth right here, it is starting to get deeper. It's an increase going from 4 to 5. And so it doesn't just start at the 70, it starts the instant you've passed that 60-minute mark, it starts to increase until you get to the 90-minute mark, and then that very next instant, it starts to get smaller. Okay, what is the deepest point? Well, it's right here at 12. And when did they float over it? At 90 minutes. Okay, so that's a point in this whole thing, that at 90 minutes they floated over the 12-foot deep part. How long were they on the river? Well, they were on the river for 120 minutes, but I'm going to write it using this favorite word today, between 0 and 120 minutes. Okay, now the next question is vague on purpose. How deep is the river? Some people want to average all those depths. Some people say, well, it gets to 12 feet, so it's 12 feet deep. But I think the most useful answer for this question is that it goes back and forth between 4 and 12 feet deep. And so I know a lot of people were starting to write these using compound inequalities, that the river is between 4 and 12 feet deep. I just want to change this. Instead of x, I'm going to write here a y, because we are talking about this line going back and forth between 4 and 12, and the range is the y's. All right, the next thing you have to do is graph it, and so these are just points that were given. So you put a point here at the 4, and then at the 6, and then at the 8. And you're going to keep graphing those points, but we also need to connect the dots because we are moving sequentially through time. We don't just go to 40 minutes and then suddenly at 50 minutes we're there. Later, we have to go through every second in between. And I know they only took the depth measurements every 10 minutes, but they had to hit every second in between there on their float down the river. So that's why it's going to be a continuous graph, and I'm not going to finish it on that page. I'm going to go right here and see if I can quickly graph this. Remember that these are points. So this represents over 20, up 8, over 30, up 10, over 40, up 6, etc. Excuse me. Okay. Oh, sorry, this is taking a long time. I hope that you're graphing it too. Okay, now down at the bottom, number 7 on your classwork, we're going to talk about these key features of the graph. We're going to start with the domain, and these 6 things that we're going to talk about today are going to be important for the future. Next class, we're going to learn about some more characteristics of graphs, but today we're going to just talk about these three. So if you remember that the domain is the set of x's, it's your inputs. For this particular problem, what we're talking about for the domain is all the x's we're using. So I'm kind of moving this way. You can see this little pointer light thingy. So I'm asking you, well, how long are they on the river? What is the input? That's the time. It's going this way. They were on the river from 0 to 120 minutes. That's how long. That's all the x's we were using. That's what this axis down here is telling us. So I would write that by saying they were on the river between 0 and 120 minutes. And they were there exactly at 0 and exactly at 120, so I put the little equal to line underneath. Now range is going this way. Range is y, and y is the horizon, like the horizon, right? So what range do we have? What y values are we using? Like if you follow this pointer right here, I'm not using any y values down there. In other words, the river was never 2 feet deep or 1 foot deep when they were on it. So that's not part of the range. So our range went, oh, I just said it wasn't. Our range goes from 4 to 12. Remember, the river was between 4 and 12 feet deep. And so that was the range. And range is y, so make sure you use y when you write the range. Now, the maximum points are the points at the top of a mountain in a neighborhood. So for us, this mountain right here is going to be the highest point around. So the top of that mountain is one of the maximum points, and the top of this mountain over here is also a maximum point. So they are points. We need to write them as points. A point has parentheses and a comma. So what is this first point over here? Well, I went over 30, up 10. And my second point, I went over 90, up 12. Those are the maximum points. They're the tops of the mountains. It's not the highest point in the world, because that would be like the global max. It's just both of the local maxes. That's the highest point in the neighborhood. So I know that this point over here at the 90, that's the tallest one on this whole graph. But this one over here is also maximum because it's taller than everything around it. Also, if you think about those green arrows I drew at the very beginning, going up and coming down, and going up and coming down. So you can kind of see just from the arrows that it's increasing to a maximum, and then it starts decreasing, and then it increases to a maximum, and then it starts decreasing. Okay, so a minimum point is at the bottom. That's where you're decreasing. So you can see that there are 3 minimum points here. So one minimum is at 0, 4, and another is at 64, and then the last one is at 125. Those are the 3 minimum points. They're at the very bottom after it's been decreasing. Okay, sorry I had to stop and take a little break, so I can't remember exactly what I was saying before. Hopefully this video is not super confusing. We're going to answer the question, when is y increasing? Well, we're going to look up at this graph where I have those green arrows. When y is increasing, that's when the arrow is going up. That's when this function is getting bigger. In other words, it's when the roller coaster is going up the hill if we're traveling from left to right. So this function is increasing. Doesn't it sound familiar? It's kind of like when I asked you the question about when is the river getting deeper? Yeah, it's the same idea. So we're going to use a compound inequality to say, well, this function is increasing between 0 and 30. Is there another place where the arrow is going up? Sure. It was between 60 and 90. Can I put the little equal to bars underneath there? That's what people want to know all the time. Well, at the actual point of 30 or 60 or 90, the actual point, you are not increasing or decreasing. You're actually flat. That's that Wile E. Coyote moment where he just hangs in midair for a second and then he starts going down. So no, you're not increasing at the point of 30. You're neutral. You're negative. You're not negative. You're neutral. You're flat. Not increasing, not decreasing. I was talking about decreasing.
let's write down the inequalities of when my function is going down. When are the values getting smaller? That's when those arrows are going down. So it's decreasing between 30 and 60, and also between 90 and 120. That's when those arrows are going down. So if I were to chop this right here, that's the interval. This whole time my function was getting bigger. This whole time my function is getting bigger. That's what that means. Okay, so we have a couple more examples to look at, and we're going to start off with the domain. Domain is listing all of the x's. All of the x's that we're using here. So for my domain, looks like I started when x equals 0 and I ended when x equals 70. Did it include exactly 0? Yes, it did. Did it include exactly 70? Yeah, we went right up to day 70. So that's the domain for this one. The range is the y values. Y is the range. What are my y values? Well, I started down here at 0 with no snow, and the highest snow level I got that year was at 270. So I know that on the graph it goes to 300, but our snow level never actually got there. So we're going to say that our range is all the values between 0 and 270. Remember, it's the range, so you're going to write a y. Okay, what are the maximum points? Maximum points are when you're increasing on one side and decreasing on the other. Top of a mountain. So this one has 2 maximum points, this graph does. One of them can be found at 10, 100. And the other maximum point looks like it is 40 and then 270. Those are the maxes. So if I forget in the future to say point on there, you just have to remember, oh, when I ask for the max, that's a point. It's the highest point around. Where is the minimum point then? Well, this one's going to have 3 because it's going to be the lowest point in the neighborhood. It's going to be at the very beginning, and then when it was this little dip, and then at the very end again. So the minimum points for this problem are 0, 0 in the beginning when there was no snow. Also at 20, and then what is that? 50, 60, 70, 80. And then the last one will be at 70 and 230. Okay, when is y increasing? When is my roller coaster going up the hill? Well, we could color this and say it's increasing. It's going up here and here. Those are the places where my function is going up. We could also color where it's going down from left to right. So the blue sections are where it's going down, and the red sections are where it's going up. So when is y increasing? In other words, describe to me the intervals of those red sections. So it's increasing from 0 to 10. It's also increasing from 20 to 40. Oops, no, there we go. Don't put your equal to bars on there because it's not increasing at exactly 10 or at exactly 20 or exactly 40. It's neutral at those places. Okay, so then when is y decreasing? That's when it's going down. So y is decreasing between the 10 and the 20. Also, after 40, until you got to the last day, which was 70. Okay, I think increasing and decreasing is the hardest part about those. Here is another one. Let's do domain and range first. Domain, all the x values. So I'm going to scan from left to right using my laser scanner. Am I using any of these values? Nope. Nope, nope. Beep. Just like that. So when did I start using values? I started using x values at -5. And I stopped at +5. That's my domain. Okay, range. We're going to do the laser starting down here. No, 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 no. Beep. Okay, so for my range, I was using values starting at -3 is when it started to beep. Range is my Y, and 7 is where it stopped. Okay, maximum points. There are 2 maximum points. They're at the very top right there. And so the location of those points, -5, 7. Also, +5, 7. Oh, sorry for yawning. The minimum points. Where's the very bottom of this mountain, of this valley? Right there. Minimum point is at 0, -3. Now I'm going to color code this. When is Y increasing? Increasing, we were doing blue before. That's when it's going up the roller coaster. Y is decreasing right here where it's coming down the roller coaster. Okay, so then to answer the question when is Y increasing? It starts at 0 and it stops when X is 5. I'm not asking how high it's getting. Remember, I'm not asking about how low or high it's getting. I'm just saying when. So this group of numbers right here describes when it's increasing. And so then this group of numbers right here would describe when it's decreasing. It's decreasing. Ay, caramba. Oh, sorry. It is early in the morning and I am sleepy. Y is decreasing from -5 until you get to 0, and then the roller coaster turns and starts going up. Okay, for 25, they actually restrict your domain and your range, and you have to draw the function. So this says your domain has to be between -1 and 9. -1 is over here, and 9 is over here. So I'm not allowed to use any of the values outside of that range. I've got to be using X values in here. But now my range, they've restricted to be between 5 and 12. So that means that I have to use Y values from this section. In other words, this rectangle right here is describing the only place that my function can live. And then there's one more restraint they put on here. It has to have a max at 411. Well, where's 411? It's right here. So one of your high points needs to be right there. The rest of it is up to you. Make sure it's a function. So you could have this thing come down, have a max there, and then go down like that. That would work. You could also have done it the other way, where you start at the bottom, and then there was a dip, and then you ended up. Something like that. That's going to be your function. Okay, so on your homework, oh, sorry, oh, I'm so sleepy. I'm actually going to just maybe review how to do this last one, number 22. A recursive formula and an explicit formula. So looking at this, we have some gaps here. This is going from 2 to 7, and this is going from 7 to 9. But I bet I could predict what's going to be inside there for when x equals 8. And it's probably going to be 15,625 times 5, I'm guessing. And now you're literally just looking at that and trying to be a detective and figure out what's the pattern. I don't know. But since everything ends in a 5, I'm guessing that timesing by 5 is a pretty good guess. And yeah, when x is 8, y would have been 78,125. So multiply that again by 5 and just make sure. Yep, 390, 625. So that means that my pattern is multiplying by 5. And when we did recursive equations, we said f of x equals f of x minus 1 times 5. That's our pattern. And where did we start? You could use any of those values for your starting place. I just picked the first one. Okay, and then for explicit, that's the one where we were saying, okay, this is geometric because we're multiplying. So we're going to multiply by 5 every time. That's our pattern. That's what goes in the parentheses. And then we have x minus, let's use our second term, and our second term was 5. So that is our explicit function right there. Okay, thanks for watching. I hope this helps. I hope this helps you understand 6 characteristics of functions.